So today, for our 4-7 lesson about apply the law of sines, we're actually going to use the textbook Blitzer 6.1. So what we like about Blitzer is it splits what could be a really big lesson into two different parts, so we can just focus on law of sines today, and the problems are going to be a little bit easier too. So law of sines is still part of 4-7. But we're just really doing like the first half of it. So in a triangle, and this is the way we always label triangles, wherever I label angle A, I use a capital letter. And then across from that is my side A, and I use lowercase. And then when I label angle B, across from that would be side B. And again, uppercase for angles, lowercase for sides. And then I'd have angle C and side C. And it doesn't matter if I had written A here first and then gone with C, because A is always going to be between angles B and C. If you rotate the triangle around, you have the same thing. So that's the way we always label. So law of sines is if I take the sine of angle A and divide it by side A, it's the same thing as the sine of angle B over side B, or sine of angle C over side C. And we could even reverse that or flip it, I guess is what I'm saying. So A over sine A, B over sine B. And you're probably wondering, why do we need this? Well, we've been working a lot with right triangles, and we know how to easily find all of our sides and angles with right triangles. But what about if we don't have a right triangle? So these are properties. This is a property, and we'll learn another property here in a couple days, law of cosines, that we're going to use for oblique triangles. So triangles that are not right triangles. And it still allows us to solve. So when they say solve the triangle, remember what they're really getting at is that we are finding all the angles and all the sides. That's what we're doing. So I'm going to go ahead and label this first one. You're going to draw a picture on your homework every single time. My angle A is going to be 94 degrees. So across from that is side A, which I don't have. I'm going to make my angle B over here, and across from that is 25. And then my angle C is 67 degrees, and across from that is side C. So really, to get going, I need like an angle and a side that go together, right? I need to have this. So I don't have side A, I don't have side C, but if I had angle B, I also have side B, I'd be able to use that. So my first job is going to be to find angle B, and I know that my angles in a triangle add up to 180. So 180 minus 94 minus 67, and so my angle B is going to be 19 degrees. And then I need to go through and actually use my law of sines. So I'm going to label this 19 degrees. So I can say that the sine of 19 degrees over 25 is going to equal, let's see, do we want to start with, let's start with A. So we'll say sine of 94 degrees over side A. And then I've just got to go through and do some algebra here. So I'll multiply both sides by A, multiply both sides by 25. So I'd have A sine 19 degrees equals 25 sine 94. And then to get A by itself, I'd have to divide by the sine of 19. And so A is going to equal, when I plug this into a calculator, 76.6. So I've got my angle and my side so far. I still need side C though, right? Usually they're going to give us 3 things, right? We're going to have to find 3 more things. So to find side C, I'm going to start it the same way I did over here. So sine 19 degrees over 25 equals sine 67 over C. And then I've just got to go through and do that algebra again. So today we are solving triangles that are not right triangles using the law of sines. So when we're solving for sides, this works pretty well. It's when we're solving for angles that we're going to have issues. Let's see, our last side is 70.7. So when we're solving for sides, it's easy. Solving for sides is easy. And I say solving for sides because I didn't have to do law of sines to get an angle, right? My angle I just got by subtracting. And then I really had to solve for two sides. So solving for sides is easy. Solving for angles, that's going to be the difficult part. And here's our issue. Our issue is the way the sine function works. So my issue is that, and this is just like off to the side, extra info that you don't necessarily need to write down. My issue is that if I take the sine of, say, 50 degrees, let's do that on a calculator really fast. I get, and let's do a bunch of decimal places, like 4. I get 0.7660. Okay, so now let's look at the sine of 180 degrees minus 50 degrees. So 180 minus 50 would be 130. So if I do the sine of 130, let's see what happens. I get the same thing. So we have this ambiguous issue where when I take the sine of two different angles, I can get exactly the same thing. So when I'm solving for an angle, it's really hard to know, like, which one am I looking at? Now, if my first angle was 50 degrees and my second one was like 230 degrees, I would know that it couldn't work, right? Triangles have to add up to 180. But because it's only 180 minus that first angle, it's still pretty small. And so I have to kind of think about that contingency here. So when we're doing solving for an angle, there's going to be some extra steps. And sometimes there'll be no answer at all. Sometimes there'll be one answer, and sometimes there'll be two answers. And we're going to go through all those different scenarios. So I'm going to go ahead and label this triangle 127 degrees, and then I have side A as 63. I'll put B over here, 42, and then C is over here with side C. Okay, and then we do have the 127 and the 63, so we can get started right away. So sine of 127 degrees over 63 equals, and I think I'm going to go for, we have to go for B first, right? Because we have side B. We can't go for C. We don't have either the angle or the side. So I'm going to write sine B over 42. Okay, and then of course we're going to multiply both sides by 42, multiply both sides by 63. So 42 sine 127 equals 63 sine B. And then we would divide by 63. And then I would have to take the sine inverse to get B by itself. So B is going to be the sine inverse of 42 sine 127 all over 63. So that gives me an angle for B that is 32.2 degrees. Okay, so what I always do every single time on these problems now when I'm solving for angles with law of sines is I also figure out 180 minus that angle. And that would be 147.8 degrees. Now, does it work in the triangle? Does this also work? So my issue is that my angle A is already 127. So 127 plus 147.8 degrees is greater than 180. So no. That means I only have one angle answer in this one, 32.2 degrees. So every time we're solving for angles, we have to investigate and make sure that there can't be a second angle. So once I have angle B, and I'm sure there's only one, it's going to be pretty easy now. I'm going to find angle C. C equals 180 minus 127 minus 32.2 degrees. So C is going to equal 20.8 degrees. I know on your homework we've been doing nearest degree. I have no idea why before in my notes I decided to do an extra decimal place, but that's just what we're going with right now. But normally we would do nearest degree for angles and then tenth for sides. So now that I have C, my angle C, I can find side C. So I'm still going to start with sine 127 over 63 because I didn't have to round either of those. That's going to be more accurate. And then I have sine of 20.8 degrees over little side C. And then I can go through and just do all my algebra again, right? So C sine 127 equals 63 sine 20.8 degrees. So let's see. C is going to equal 63 sine 20.8 degrees all over sine of 127. And so my C is going to equal 28.0. So we have angle C, side C, and angle B. Make sure you are putting degrees on all of your angles. You have to have degrees on them. All right, so that was our first case. So we're going to look at another one. So on this one, let's see, I have angle B is 52 degrees. Side B is 4.7. Angle A, I don't know, but side A is 6.5. And then we'll do C and then little c. All right, so it looks like we have to start with B again. So sine of 52 degrees over 4.7 equals, and then we're going to do, we have to go with A because we have side A. So sine A over 6.5. And then we're going to have to go through and do our algebra again. So multiply both sides by 6.5, multiply both sides by 4.7. So 6.5 sine 52 degrees equals 4.7 sine A. And we divide by 4.7. Equals our sine of A. And then we would do the sine inverse on both sides. So when we're taking the sine of something, we're getting a ratio of the sides. When we do the inverse, it's giving us that angle instead. So we're starting with the ratio of sides. So that 6.5 sine 52 degrees over 4.7 would be our ratio of sides on a triangle. And then we're finding our angle. So this one's really weird. When you plug this one into your calculator, it says error. And so what that means is that there's really just no solution. So there are some great pictures in your book to show you like all the different ways that this can look. But for our purposes, we know that there could be one solution, there could be two solutions, or there could just be none at all. And like I said, we're looking at each of those cases. So sometimes you're just not going to get a solution. This triangle just doesn't work. So it's like for the way these two sides are and the way this angle is, like it's just too short and it doesn't connect and make a triangle. So last one, and if we've had one with one solution and one with no solutions, you can kind of guess this one's probably going to have two. So let's see, we have 62 degrees, and that's across from side A, and then angle B, and then 34, and angle C, side C. So we have to start with angle A again. So we're going to have that the sine of 62 degrees over, let's see, 32, and then I think we'll go for B first. Well, we have to, right? We have side B. So sine B over 34, and then we'll multiply again by 34 and 32. So 34 sine 62 degrees, 32 sine B. So just lots of algebra today. The math is not difficult, especially for the straightforward problems like our first one. It's just where we have these two sides and one angle to start with when we have to solve for an angle that it's tricky. All right, so I have my work for B all set. So B is going to be equal to, let's see, plug that into our calculator, 69.7 degrees. So again, I always have to check for the second one. So 180 minus 69.7. And that would give me 110.3 degrees. Okay. So can those both work? So if I add the 110.3 with the 62, I have something less than 180. So they're both going to work. Triangles can't be more than 180. So we have two cases. We're going to have a case where B is going to equal to 69.7 degrees, and we're going to have a case where B equals 110.3 degrees. So we're going to have to solve both of those triangles. So I still need to find angle C and side C, but angle C is easy. So if I start with a 69.7, I have 180 minus 69.7 minus 62. And so C is going to equal 48.3. So I have B, I have C, and then to find side C, I need to use my law of sines again. And I've been doing sine of the angle over the side every single time. We really can reverse that. Let's just do C over sine 48.3 equals, let's see, we need to go back to 32 over sine 62. I like it better with the angle on top. I feel like it's awkward to multiply both sides by like the sine of something, but it doesn't really matter. So I'd be multiplying both sides by sine 62 degrees and sine 48.3 degrees. So we'd have C sine 62 degrees equals 32 sine of 48.3 degrees, and then divide out. So just lots of writing today. But I think the only tricky thing is this more than one angle. Okay, so for C here, we get 27.1. All right, so there's one case. The other case is if we have a 110.3, and then C would be 180 minus 110.3 minus 62. So C would be just 7.7 degrees. All right, let's just box these in too, because this is our OR case. And then we're just basically doing the same algebra over here. C over sine of 7.7 degrees. I'm going to try and write smaller and cram it all in. And then we do need to look at one more formula that's going to be pretty easy. The formula that we learn for the second part of this lesson is a lot longer, but it's actually, if you can figure out how to plug it into your calculator, that's always our struggle. It's more straightforward. We don't have this weird thing where there's more than one answer. All right, so 4.9. So let's just kind of go back through law of sines real quick and make sure we understand. So when we are using law of sines to solve for sides, we're good to go. Those are easy. So we just get our answer, we're fine. But when we solve for angles, because when I do the sine of an angle and the sine of 180 minus that angle and I get the same thing, I have to be kind of worried. So when we're solving for angles, whatever my first angle is that I solve for, I always do 180 minus that and check to see if that works or not, because I know that the three angles in my triangle together have to be equal to 180. So sometimes that second one doesn't work, you just get one answer. Sometimes you don't even get a first answer because the triangle just doesn't work. The side's too short. And then sometimes you get two answers, where when you do 180 minus that first angle, you get a second answer that could work. And so we have to worry about that. So solving for angles is a trickier part. Last part of this is area of an oblique triangle. So when we don't have a right triangle, we still care about area. And I know in school, like we'd split it up, we'd find the height, we'd do some other steps, but there's this really cool formula so that we don't have to. So the formula is 1/2 AB times sine C, or 1/2 BC times sine of A, or area could be 1/2, what do I not have? I have AB, I have BC, AC times the sine of B. So what we're really looking at when we write out this triangle, let's just go ahead and label A, B, C, little a, little b, little c. So if we're looking at like that first one, AB sine C, so here's my C right here, and A and B are those sides. So you're looking at an angle and the included sides is what we have to have. So we're going to just use this triangle formula really quick. So I would not do this if I had a right triangle. If I had a right triangle, I would just do 1/2 times the base times the height. But if I don't have a right triangle, like in this case, I've got a 46 degrees here and I don't have anything else, then I would want to go ahead and use this formula. So that's what this is for. It's not for all the time. It's for when you don't have a right triangle. If we have an oblique triangle and we have an angle with the two included sides, then we could do this. So 1/2 times 10 times 14 times the sine of 46. And so A is equal to about 50.4 units squared. So there we are. So this is the end of our lesson. It's 4-7, part 1. We're using Blitzer 6.1 for your homework. Apply the law of sines. So please ask some questions in class.